Everyone, welcome back. Please take a second to pause this video and read through the question and then meet me back here for the solution. Okay, jumping right into part B, our goal is to write the equation of the tangent line to the graph at the point where x equals 1, and then use that to approximate the value of f of 1.2, and then finally state whether the approximation is greater than or less than the actual value. Note that that is going to require a more advanced topic of concavity. So if you haven't learned that yet, don't worry, but I think you will still benefit from the conceptual explanation. Okay, so let's start with the equation of the tangent line going up to my table of values here. This is where my x is 1, so my y value, or f of 1, is -4. So my point is going to be 1, -4. And now my slope is just given by the derivative when x is 1, which is equal to 5. So now plugging that in to point slope form, I'm going to get y minus -4, which is the same as y plus 4, equals m times x minus 1. Now, personal preference, I'm going to go ahead and switch this into slope-intercept form. So I'm going to distribute the 5 in. I'm going to get y plus 4 equals 5x minus 5. And then I'm going to subtract the 4. So I'm going to get y equals 5x minus 9. Okay, now I have to figure out, so this is the equation of the tangent line. Now I'm going to use it to approximate f of 1.2. So f of 1.2 is approximately equal to 5 times 1.2 minus 9. Now I'm going to think of 1.2 as 6 over 5, just so that I can do it in my head. Again, minus 9. Then I'm going to cancel out the 5s. 6 minus 9 is -3. So f of 1.2 is approximately equal to -3. If that's all you came here for, please feel free to stop watching now. Now from here on out, we're going to discuss concavity and how to tell whether our approximation is greater than or less than the actual value. So something that was given at the end of the question, it says the second derivative of f has the property that the second derivative of f is greater than 0 on the domain given. So -1 is less than or equal to x is less than or equal to 1.5. Sorry, I think I said -1. I meant to say -1.5. Anyways, so because the second derivative is positive, that tells us that it's concave up on this interval. So I'm just going to draw you something like this. This would kind of be a classic display of something that's concave up. So what's happening is, let's say we're looking at this point, our tangent line might look something like this. So again, it would pass through the point 1, -4, and it would have a slope of 5, which clearly you can see my drawing isn't very good because this looks like a slope closer to 1. But anyways, note that if you were actually doing this, it should have a slope of 5. So now what's happening is we're using the equation of this tangent line to estimate the value of 1.2, which is going to give us, let's just say it's like right there. It's probably even closer, but again, not to scale. So let's say it's this point A. So what's happening is because this graph is concave up, you can see that point A is below the actual output value, which we could call like B. Right? So because it's concave up, A is less than B, which tells us that our approximation is less than the actual value of f of 1.2. All right, thanks so much for watching.